Welcome to Telco Bridge's ProSBC TechTraining Module 151. In this module, Luke covers IP network configurations, SIP stack configuration, profiles, network access points, and NAT translation considerations. So listen on.
Want to know, need to know, and material like this. Trying to touch everything that you may need at some point. So here what I want to touch is IP networks, which is something fairly important in the SBC. Then the SIP profiles and network access points. Alright, so in general what you need is, we talked about that this morning, one management interface and at least one LAN 1 connection. If you want to have LAN and WAN separated, here we have two interfaces. These ones are SBC protected. If you want to have a 1+1 system, then you can put two control networks. These don't go through the SBC, right? These are independent interfaces directly in the kernel of the CentOS. And if you have transcoding, you need to have two transcoding networks. So this is...
On the control network.
Sure.
So when we set up ours, it basically picked IPs to use. And we had to give it its own VLAN basically, or its own subnet to talk to each other on, right?
Yes.
Will those IPs be the same for every 1+1 configuration? Because in thinking about it, we couldn't set up a test 1+1 on that same network because we have IP conflicts.
Yeah, so somewhere in the configuration, and I hope it's there, you can do change internal subnet. Did you see that? No, but that's in the initial configuration. Okay. So you have it tells you, do you want to be primary or secondary? Which IP interfaces you want to use, and then the next page is internal control network. So you can choose a VLAN, and you can change the default IPs that are there.
I don't remember seeing a way to change it, but I probably went through it so fast I missed it.
And I actually don't remember seeing it as well. Yeah. But we should verify if it's really there.
I was just thinking because we're thinking about we've been setting up what will eventually become production. We're like, well, we probably should have a test one too, and I'm like, I may need yet another V-switch for that network, you know?
I see what you mean. No, you can change it. I just don't remember seeing it, but it should be there, okay? It's there, it says change internal.
I just want to make sure.
Okay, change internal subnet, right?
Yeah.
You click on that.
Internal subnet, so by default is 172.16, so then you can change it and change to what.
Yeah, the reason we use a default subnet like that is because when we ship our transcoding units from here, it has pre-programmed IP addresses which will fit automatically in that network. That's the only reason, right? But otherwise you can choose any, and you can change it, but you need to change it at the beginning. Otherwise you need to redo the host role change to change that. So in the configuration, you have the Ethernet port. So these ones here, you see, you cannot change them. There's no column to say delete, change. These are the ones we pre-configured in the initial configuration. So these are the control interface we were talking about here. You see, there's one on the primary and one on the secondary. Right? So each one has their own control 0. It's a different IP, but the name of the port is the same. All of them will have something like this. These are LAN 1 interfaces here, okay, and they are on both A2 and A3. They will show up. Of course, when you configure the secondary one, they need to have the same name so that they can be linked together, right? So they will be linked by the name in the configuration here. You see this one here is a management interface. Alright, so again, this cannot be changed at this level. If you want to change something here, you need to go in the host and change network device roles. So you can change what they are meant to be, which MAC address is assigned to which VLAN. Or you can do change host role, so then you can even change if you're primary, secondary, plus the network interfaces. Is that okay? James, you sure?
I think so.
Write down your question if you don't want to ask it now. Alright, so we saw this before, right? If you have a standalone SBC, you have management, LAN 1, and maybe other LAN 1 interfaces for other purposes. If you have a 1+1 system, then you need to have two more networks, control 0, control 1, between the two SBC. They will talk to each other. Alright, so choose, I will show later, but choose who is the master at any one time. And we have active application and we have active standby application. So there's different ways of controlling who's the primary of each of the types of application, but they all communicate with the control 0 and control 1 interface. Okay. And then if you have transcoding, you need to add two more networks. They are still LAN 1, but they use specifically for transcoding. So that's why we call it trans 0 and trans 1. And you need two of them. And here on the transcoding device, well, control 0 actually is named ETH0 and ETH1. And transcoding 0, transcoding 1 is VoIP 0 and VoIP 1 on these devices. But otherwise, it's just like that. So you need to make sure in a VMware environment that these networks are, sent to the transcoding device or a bare metal as well. The transcoding, Nicole, do you think it can be the same LAN? Can we use the same LAN for transcoding? Or it has to be two separate interfaces?
You mean LAN and WAN?
Trans 0, trans 1, can it be?
Yeah, it can be the same subnet.
It can be the same subnet, but you still need to define one more interface?
The chances 0 and 1, they are just redundant. You can have only one. It doesn't have to be two.
You can have only one?
Yes.
But can you have 0? I mean, can it be a LAN, this same LAN interface?
No, my question was if it can be part of the same LAN. I mean, same as LAN.
Ah, okay. So the answer is yes, right? Can be in the same network.
Yes. Well, I mean, the chances 0 and 1 is preferable to be on different. This is for network redundancy, right?
Yeah, trans 0, trans 1, but compared to LAN here, they could be in the same network
Yes.
as LAN, yes.
Yes, they don't interfere each other.
Okay.
On that same line, though, we were trying to, since we're behind a firewall, we were trying to just have different IPs on LAN and WAN. Same subnet, we didn't seem to be able to get past it. We ended up having to put them on different V switches in order to
You can have this on the same, you mean LAN, the two interfaces like this with the same subnet, right? I think we can do that, right?
We just didn't configure it right.
I don't know, we couldn't get it to work. We were on two separate subnets. We couldn't get it to work.
Because we also tried it as two different interfaces. If we combine them, we could do it.
Yeah, we did not combine the
Nah.
interfaces. There were definitely two separate interfaces.
Okay.
Yeah, that's why we couldn't put them on the same subnet. Because you'd have a routing nightmare. And at that point, we would have had to start all over
We
again.
ran
So we didn't do it. So we put it on a second network.
We ran into issues with the subnet not asking other stuff. Like,
Right.
just couldn't do it.
It's possible it's not completely fail-safe in all scenarios, yeah.
That's where you have to get fancy with your DNS settings. Too, right? You have to include the 127
Right.
DNS.
Yeah, maybe.
Well, it would have to be your primary DNS.
Mm.
It's just easier than that, trust me.
Yeah, exactly.
Separate them. Just separate them.
So then, if you continue and configure the stuff, you only can configure the LAN WANs, right? That's the only one you can configure here. You see delete, and you can add some, create new virtual port, but you can't do that on control 0, management 0. It has to be only LAN 1 interface. That's what you control here. You probably saw that already. You can do untag or use VLANs. You can have multiple VLANs on the same network interfaces. And you can define multiple IP on the same or different VLANs. Right? So there's maybe one condition that doesn't work, but most cases you can do that. Right, so VLAN, just things that you have to be careful here. When using bare metal, you have direct access to the VLAN, so the switches in front need to have those VLANs configured. On a virtual machine, these VLANs are controlled by the hypervisor, and you need to configure the network correctly. Sometimes it's a bit tricky to do that, and you have actually two choices. I've tested it on VMware. I don't know on the other platforms. You can probably do a similar thing. Either you use on the virtual machine, on the SBC, all untagged, and the virtual machine will tag them, okay, by the hypervisor network interface will tag them, or you can use on VMware port 4096, right? And then you can configure all VLANs on there. So then the VLANs are configured from the guest OS or the SBC. All right, so different ways to do that. Once you decide on one way, you need to continue configuring the same way, right? What else did I want to show here? Well, the IP interfaces. Yes, this I think you know already. Yeah, nothing else here. So new IP interfaces, DHCP or a specific IP like that.
Can you go back to...
Two slides?
Yeah.
Yeah.
You see, when I look at your bare metal, it says you use direct VLAN configuration.
Yeah.
It must be configured in the Ethernet switches. So that means the VLAN has to be configured on the port?
Yes.
I cannot define it in the TV router software, because let's say I have 4 ports, and I'm bounding all 4 ports, do like an Ether channel.
Yeah.
In the TV router, can I define the VLANs there?
You can define the VLANs there, yes.
Oh, we can?
Yes.
But only for LAN and WAN, not for control or
Control 0 you can, but you need to do it.
On the switch.
You need to do it when you initial configuration. Okay, initial configuration, then you can configure this. Management, same thing. You need to do it before even you connect to the system, right? So you can do that. The only way to control it in the SBC are the LAN ones.
Okay.
Once you configure an IP interface, there will be a RTP port range created automatically, which can be used when you configure your SIP networks. By default, this is the port range, but you can obviously change that to another port range or create even new port range on the same interfaces for different reasons. Okay? So a SIP call will use one of those ports when it makes a call. Okay? And these are things we see in the web interface, sometimes owned by, right? So that's a, like, who uses these RTP port ranges, right? So it's good sometimes to reference back what is using what.
Does that limit the RTP? So if the port range is 20,000 to 40,000, there'd be no RTP traffic outside of it.
Exactly.
So that's the that's the UDP range.
Yes. The UDP range that the RTP port will be on. Yes.
Both the NAP, on both NAP ends. So whether it's your carrier or whether it's your customer NAP.
Well, the one that's using this snap, yes. So let's say if you have something like this, well, everybody's going to be using 20 to 40,000. But you could have your local use this and your remote using maybe only 7,000 to 9,000. Right.
Okay.
So this, if you have to go through firewalls and stuff like that, then maybe you need to reduce the scope a little bit.
That
Yeah.
might actually help.
Yeah.
Yeah, just what we were talking about.
Yes.
Yeah, okay.
And you need to have double the amount of port range here compared to the number of session you want to use on that NAP. Okay, so because the odd port is always reserved for RTCP. It's only going to use the even ports for every call, the pair seulement. Impair, c'est les RTCP. Okay, so the first call will be 20,000, second call 20,002. And 20,001 will be the RTCP of the first connection. Okay. However, RTCP, I don't see it used very much in the field, but we support it. It's there by default. So, okay. What else? Yeah. So once your network is configured, then you can assign SIP stack. So stuff that you can configure in the SIP stack. It's all of these are global parameters, right? Like I said early on, you have the quirks here that applies to all the system, but actually all of these apply to all of the system. And these quirks, if you change something, it's going to restart the SIP stack, and then you lose all the calls if you want to do that, right? So quirks, for example, is add the space after the column or something like that in the SIP message, right? So we've seen all kinds, with all our experience in SIP, we've seen all kinds of implementations, and sometimes you need to do a space. So we can force to have a space, and so we have all kinds of quirks here to allow doing all kinds of installations. The default quirks that are enabled works for 99% of all your installations. Okay. Then you have SIP header parameters. Everything that is included in the SIP message, for example, the user agent field, you can change what is being sent in the user agent field, or you can enable provisional acknowledges. Okay? So this adds messages in the SIP to confirm other messages. Okay, pracs. Okay. So you can enable this, but that's when you enable this, it's for all the system. And then you have SIP session timers. Again, this is on all the system, and refresh is sent on SIP call. So when you do a SIP call, every X amount of time, it's going to send a re-invite to say, are you still there? And it's going to just reply, yes, I'm still there. Okay? So this is good for if you think some of your SIP destination will go away, then this will drop the calls if there's no answer from the other SIP stack. Okay? You can configure the refresh timeout on SIP. Okay? Now we've seen sometimes session timers, it doesn't work perfectly well in some destinations. So if it doesn't work, we have to disable it to make it work. Okay, so just a SIP call flow here, an example. What I want to show here is when you look at a trace viewed from the SBC, there's 4 SDPs actually, right? So the SDP that is received from the initial side, well, the SDP defines the codecs that are being used, right? And then you have the SDP that we send from our side, and then the SDP received from the other side, and the SDP we send. So each of them could be the same or different. Right? And these are all the codec negotiation scheme I was telling you about this morning. Okay, in the SDP it includes the IP address, UDP port that's being used, or the RTP UDP port that's being used for the conversation, the codecs, and yeah, so then you have here, maybe you have early media, maybe not, right? And maybe you have your, at the end here, you have your full, well, RTP is here, right? So you have full RTP. And then it could be G711. For example, if it's G711, it's 20 milliseconds per packet. You get about 50 packets per second being transferred from end to end. Okay, the port here will be changed, the IP will be changed, the port will be changed from incoming to outgoing. Right?
The port will be changed.
The port will be changed because here when we send the invite here, we will say, well, we want to use port 30,000. And here maybe he sent, I want to use port 15,000. Okay, so here we'll receive on 30,000 and we'll send to 15,000.
So it still stays within the range, right? So 20,000.
It's two different ranges.
Oh.
Two different ranges. You have the range for this network here and you have the range for this network here. Right.
Unless they're sharing.
Sharing? Yeah, if they're sharing, they could be used the same. Yeah. Same range. But don't forget that what he wants here and what we want here could be different. Right? We just have to agree that I'm using 30,000 to receive, you're using 6,000. Well, 6,000 not a good number, but 8,000 maybe to send. Okay? We just have to agree both sides.
But how does that affect the bypass media?
Bypass media, well, both. When you say to the other side, you have to say the port of the first guy and the IP of the first guy. Yeah, to pass it through. Yeah. Here it's always with the RTP passing. Everything is a bit different with RTP bypass.
Well, I had to get my head around it.
And we need to add some slides on that. So here we have early media. Either we get a 183 or a 180. We've encountered so many scenarios. 180 without SDP, 180 with SDP, 183 without SDP. All the scenarios possible. And the other side wants all the scenarios possible. So we added some parameters very recently in the SBC to allow more control of what we want to do. Right? So if it's 183 all the way, then the early media passes all the way around. But here, if it's 180, well, the default is that there's no early media that is passed in, no ringback tone that is passed. But we could, if we have the transcoding device, insert here early media. Oh yeah, I have it here. There you go.
And that's the audio file you were talking about.
Yeah, exactly. So file is played from the transcoding device. So you choose the file to play, and it's going to play this file as early media here. So really played from the transcoding device out to the user. So, but we're not receiving anything from the outgoing. We're just sending it here.
You gotta need the transcoding.
Yeah. Unfortunately, you need.
Can you use that for, say, hunting between different, so say I make a customer makes an outbound call, and I have multiple trucks, and one of them just, for whatever reason, it has to try multiple.
Yeah.
And then, to provide that comfort ring to the customer.
While it's waiting.
While it's, well, yeah.
Yes, exactly. Yeah, you can do that.
And that's how you would do this?
Yeah, exactly. Well, if you receive if you receive a 183 here, well, you may just play the early media like that. But if he sends you a 180 and they're not playing anything, then we can force it to play here. But let's say if it's it may not work on all the cases. Maybe we need to verify exactly the case you want to have this working, but that's definitely an option here. So here I put 180 to 183. That's one example, but we have all the scenarios, right? You can mix and match. Well, we think we have all the scenarios covered now. Other example of SIP call flows, SIP header manipulation. Okay? So SIP header manipulation for us, it has to be done in the routing scripts. The advantage, it's fully flexible, right? You can do whatever you want, but the disadvantage is that you need to do some routing scripts, or ask our help and we can help you to do the routing script. So an example we did recently is a customer wanted to have the trunk group name or the SIP trunk name into the invite message. So what we did in the script is we just said, okay, the incoming NAP is name, and we added this in the message. Okay? So these are kinds of things you can do. But you can modify messages, add stuff, remove, use private headers, and do add private headers if you want. So all of this, but they are programmable, so they need to be done in the routing scripts. Okay? And these are the examples I was saying, right? So, oh yeah, so usually the 180, if there's no SDP inside, usually the 180 has no SDP inside, and here it says 180 with SDP as early media. So normally this is checked, right? So if we receive a 180, if there's a SDP, we say, yeah, there's early media inside, it's fine. Remap without SDP to something with SDP, or 180 to 183, so we can adjust this. And then this one here is always generate SDP, generate SDP and outgoing when receiving. Okay? So these are new parameters we did to adjust, right? So this is in the profiles. So I changed section now. Yeah, I should have maybe be more clear. The other one was more SIP. This one is more profiles. Other things you can do in the profile. The default SDP configuration is this one. And you see it's very short. It only has a 98 described here in the information. Okay. If you want to do the same thing but describe it full, you would need to do something like this. Alright, so 0 here is EULA and 8 is ALA, and then 4 is G723, and G723 has more parameters. You need to specify the bit rate if you're using NXA, and then 18 is G729, and then NXB again here.
What is Annex B on Annex B?
What is what? NXB, yeah, these are definitions in the specifications. Yeah. And for example, G729 NXB is a much simplified vocoder which gives exactly the same result as the original one, but implementation wise is much easier to do. Okay, so it requires less DSP processing to do the transcoding with NXB. So we always see NXB. So that's why if you don't specify it, by default it's going to do this. Okay. To allow, well, you can keep this default SDP configuration, but if you want the SIP message to have them all like this, you can add one more option. It's called generate all SDP parameters. So physically on the SIP line, they will be shown when it's sent out. Otherwise, it will be sent just like this. The only thing that will change in this message is the port here. So 0 is just for the definition, but it will be changed by 20,000 or 30,000. All right, it will change this part, but you'll see exactly this message going out on the SIP trace. If you want more vocoders, well, you can change this, right? Like for example, G722, the wideband vocoder, you can add it here, which is, I don't remember the number. We didn't put it here. Too bad. G722, I don't remember which number it is, but it's one of the static RTP payload types. So some of these vocoders have static RTP payload type. They are defined in the specification, this one here, 2833, and they're all defined. So if you put 0, you don't have to describe what is 0. There's a default configuration for 0, which is G7M MULA, 8,000 hertz, and very specific. Okay. And then This is up to 95. Starting at 96, these are dynamic payload types. So you can choose for any of the other vocoders, G726 or G729, AMR wideband, EVRC, any other. You can use any number. Like telephone event, it uses 98. And that's why 98 in our case, right? That's why we have to define it. If we use anything above 95, we have to define it because nobody knows what it is. It's a dynamic payload type, okay? No, this is not in this telephony event, so dynamic, but usually telephony events, they use 101, mainly because Asterisk was using 101, and that's why it was used, but you can use any number, it doesn't matter, okay?
So you have to manually enter for some GSM?
GSM is in the base 1, if I'm not mistaken.
What is it?
Yeah, I think it's in the base 1, but we can find the full list. It's on our wiki, actually. It's on our wiki, and you have it all there. So here in your SDP configuration, you can add any vocoders that you want, but it's going to be filtered with what you receive. Right? If what you receive, well, let's say you have no transcoding device, right? You receive 0 and 8, but when you send, you're going to remove the other ones, right? 418 is going to be removed because we try not to do any transcoding, right? 0 to 8. If we have transcoding, then we can add other parameters and we will allow transcoding, right? When you negotiate codecs, you take the first one. That's always your preferred one, right? So you always start with the first one. When we receive it, we will keep the one that we receive as the preferred one, and when we send, also we keep it as a preferred one. The other side can respond with a different order. Instead of 08, it could be 80. All right. So if it turns and we put 80, then I think we'll use 8 instead of 0. Okay.
But only if the initial is capable.
Only if the initial is capable. So with transcoding, if we receive 08 and we send 08 for 18, and the other side returns only 18, it's going to work. We're going to say, okay, second leg is 18, G729, right? And first leg will be 0. That's what they prefer. Okay. But if there's no transcoding, the call will be dropped. You cannot go from 0 to 18. Okay. Right? So in the profiles, there's other configurations here. You could force it to keep only the active codec. So if you receive 08 and the other side says 08 again, maybe you can keep only 0. Okay? So you can keep only 0 if you say active. So that means you cannot change mid-call to another codec. Only 0 is accepted. Okay? But compatible is usually the default mode, and it will keep all the codecs that are accepted on both sides, and in mid-call you can change codec type. That works. Okay? And I would add, I don't think I talk about it here, additionally, even if it's not defined in the codecs, you can still switch to T38 for fax transmission, or you can switch to pass-through also, okay, with a re-invite. Right, so you can switch, even if you don't define it in the initial codecs, you can still switch to fax. Okay. It's going to be done automatically. Right, and there's another option called allow other codecs here on the bottom. Okay. You may want to keep unknown codecs because the SBC can transport codecs that it doesn't know. Right? So even if there's a 105, maybe we can send a 105 and it's another codec type, doesn't matter. We can still support it. Right? So you can do this. Allow other codecs. Okay? Yeah, allow low media should always be checked. Allow audio transcoding only if you have a transcoding device. And RTP no anchoring is for James.
The only one.
Okay, in the profiles, more stuff in the profiles. Profiles are attached to networks, network access points, right? So that's why we want to configure those profiles. Enable SIP custom headers. So there's a specific parameter to say I want to have SIP custom headers. That's the only way to receive them in the routing scripts. So I think by default it's not checked. So if you're using the routing script, you need to check this parameter. Drop call threshold. That's actually if there's no RTP received for a specific amount of time, we can drop the call automatically, right? So that's a good protection. It's similar to a SIP session timer, except it's monitoring the RTP. Okay? It's monitoring the RTP even if we are on hold, for example. So on hold, we won't receive any RTP, but this feature will be disabled while we're on hold and will resume after. Ringback tones requires transcoding, so that's why here, and you can configure which tones will be played, or which file, or which recordings. Then you have local number portability option, so we can translate LRMs, right? So we can just relay, we can insert, we can route with the LRM value, so you can configure how you want to do that. There is a little matrix on our wiki to understand how to use this, right? So depending on what you receive, what it will do, what the SBC will do with those options. Okay.
Okay. So if I'm doing, let's say, lots of sites throughout Quebec and it comes in with one DID, whatever the case is, it will recognize the area code, and say, okay, I'll send it here.
Yeah, it will. You can do that, but there's specific parameters in the messages that we check.
Okay.
And this you can tune what the SBC should do with that. The default mode, I think, is just relay, right? It's just passing it by. Then you have the reason cause mapping. So again, in the profiles, if you want to change the reason cause from end to end, so let's say normal scenario, you don't change this, but for the CAPTCHA server, for example, the clear IP transnexus, we change the type of errors that we relay. Right? So you have to choose which one you want to modify, and you want to choose which one it will be. So if you receive a 606, we'll transform it to a 604. Right? This is per NAP, so you can configure it per NAP. There's other parameters in this same table. There's the route retry action that we'll see when we do the routing section. If we get a 606 error, we'll try the next route. Right? Or you can choose stop call here. So that means if we receive a 606, we terminate the call, the incoming leg. Okay? So you can choose what happens with different type of reason cause you receive. We'll see this again in the routing. It's going to make more sense in the routing. This one here is only used if you have transcoding, so we don't need this here. Codec negotiation, that's the part I said I didn't have time to complete, but that's just one example of SDP 08. So that's what you saw, 08. And then he replies with 8 only, so we keep 8 only here. And then it's G711 ELA, but there's many scenarios. And like I said, with transcoding, there's even more scenarios. So I need to do a bit of work on that. But the default configuration, I say, would work for most of the cases as well for the SDP. Okay, so the network access points, and if you're in just pure SIP world, it could be just a SIP trunk. Defines the entry points, or your local interface, and the exit points, where you will send the information. So it has both information inside the network access point. You can choose if you want to do SIP polling in there, so it's going to send SIP option messages to the remote device just to verify if it's still active. You can configure the access control list. I show you that a little bit. We're going to go through this in a second. Call emission control. So number of incoming call rate in the system for this particular NAP. And you also configure the NATing here. NATing actually, we think it's more for RTP, but we also have the configuration for SIP. So you have your local transport server here, which has your IP interface. Let's say the Ethernet port LAN, the IP interface, this one, and the port for SIP. And then you have the IP address of the destination or the domain and a remote port. Okay, so here you select use proxy address, you put the IP of the remote, the port of the remote, and yes, so this is for receiving. Okay, so then you can put a access control list like this. So you have 3 IP ranges defined, so you can receive calls on any of those IPs, but when you send the calls, it's going to be only on this IP. Right, so we can filter incoming, but outgoing is only one. Okay. If you want to route to different IPs here, you need to create multiple NAPs, and then in the call routes, maybe do load sharing amongst those NAPs.
So I can only have one IP address per NAP?
Only one IP address.
Okay.
You can also have a NAP without any IP. Right? So in our notre jargon, our internal say, we call it a open NAP. Open NAP meaning that we could receive from any IP and port, but here we will still filter. Right? Must be destined to our IP here or access control list. And then you need to use proxy address, remove this option, and you need to add accept only authorized users. So that means, well, they can't make a call unless they're registered. All right. So you can force the customers to register on this network access point. So once they are registered, then they'll be able to make a call through the SBC. If they're not registered, it's going to be refused right away. What else did I want to show here? Yeah, that's fine. I think it's weird. We can have a domain here that's for registration, domain here. TLS, I talked about this already. TLS, UDP or TCP. Okay. There you go again. TLS, TCP and TLS. Okay, we talk about a lot about SIP registration, but and that the SBC is not a registrar, but the SBC can register to something else. All right, so we can send registration information, so you can configure the NAP to send to a registrar with the username, password, what's the domain to use, and the NAP will try to register to a external system. And if it's accepted, then it's going to be able to make calls on that system. Right.
Sorry, going back to the registration one.
This one? Yep.
Open now.
Yep.
So is there we've seen, I guess everyone's seen, the fake registration trying, like millions and
Never ends.
yeah. So it is, we'll discuss this on another.
I don't think I have done a slide on this, but we have done rules, right, for some customers. Rules in the registration filtering, right?
After 3 fake registration, I mean, blacklist, VIP, or is there?
No.
Are you running intrusion detection, like,
But if it's registration based, it's no longer IP based, so how do you detect the intrusion and then block it?
Yeah. So
so you're not running fail to ban or anything there where it basically checks the log, say this guy tried 3 times, I'm gonna ban him for 60
No.
seconds or 10 minutes or proven ban.
no. There is protection on a rate, certain rate of registration, right? So you cannot have more than X registration requests. And we have registration filtering that you can do. And then you can block with some filters, right?
But you have to manually go and block it.
You have to do it manually. Yes. It's not, there's no,
But the problem we're gonna run into that is if you're saying you're not blocking and those calls, those registrations are coming in,
Yeah.
you're gonna pass it to my free switch. Free switch after a while is gonna say, I'm gonna ban this guy, the SBC.
right, I see what you mean.
Then it's totally useless.
Yeah.
Understand? Then it's just gonna keep coming and hitting me and hitting me and hitting me and hitting me. So, we fix one problem, but we create another one. Yeah.
Yeah, we should think of something there to improve this.
This is what we see so far, these registrations.
Fake registrations.
Millions, and VIP changes,
How can we recognize the fake registrations?
Just by quantity or by
3 failures.
Quantity.
On my system's 3 failures and it permanently blacklisted.
That's what we
Yeah,
do.
you
And then I
fail
have
to
to go
ban,
in
but
physically and
Yeah.
fail to ban.
Yeah, but it checks what exactly?
It checks the registration 3 times, even though if it's got the username is correct and the domain is correct.
Yeah.
Let's say the password is wrong, 3 times.
Password wrong. Okay, so what you mean?
If it comes in and it's trying to because I only do FQDN registrations, so if there's registration to come in and they're trying to hit the address, then it automatically blacklists.
Right.
Yeah.
I don't think we have that. Can you just take a note? I'm going to verify.
I mean, how would you protect against a DOS or a DDoS? If you have a soap?
No. But if there's too many, then it's going to be blocked, right? So there's a threshold to be reached, but we're not checking like did the same user in IP did the same user in IP try many times, right? So we can only say after this amount of registrations, right?
So the registration is passed down to the registrar.
Yep.
Does the registration pass it with the IP of whatever is registering, or does it act as the registrar?
It passes the IP that is received.
So it's
Pretty
passing
sure.
the IP that-
Yeah.
So that could solve your problem. If it's passing the IP that it's receiving,
It's not
then
seeing the
you're
IP.
blocking the IP that actually tried to register.
Yeah, but the thing is, it's still hitting my switch. I don't want to
Yeah,
hit
yeah.
my switch. I want to be blocked at the SBC.
I'd rather the SBC block it.
Ouais. Ben, c'est des attaques ils appellent ça des registration attacks. Là.
Right, exactly.
Donc, c'est des gens qui essayent d'envoyer un paquet de registration, puis si le SBC ne les bloque pas, ça va au registrar, puis là, son registrar est trop occupé là, à prendre des requêtes invalides. Là. Donc, there is some SIP registration filtering I know we can do. There's a call rate limiting, but we don't have the ban module there.
Okay, but when it passes it, it's passing
Yeah.
it's passing the source IP, not the IP of.
Yeah, I think so. It's a source IP, eh, Nicole?
Yeah.
Yeah, source IP. Yeah.
Et juste avant, ce que tu as dit, c'est que le SBC n'était pas un registrar, mais que
Why? Because we're not in the registration part yet. The registration is the next module. We're talking about the next module.
So here
On va le voir
you're
tantôt.
talking about passing registration requests. You're not actually allowing registration to, as an app itself, right?
Registration as
So
an
for
app, okay.
apps, can I have an app that has to register to the SBC and an app that is recognized by IP on the ACL? Or,
The NAP can register outside, but that's not what we're talking about, right?
no, we're talking
Okay,
about the NAP
incoming.
registering to the
Okay,
SBC.
yeah.
So the NAP can register to the SBC, right?
The NAP, you mean the external system?
Yeah.
Yes. Can register to SBC, yeah, but the SBC has to pass to a registrar. So we just pass it to a
So like
registrar.
a radius setup or something, is that what you mean?
Radius? No, just a SIP registration request.
It's the PBX.
The PBX,
So
yeah, or the
essentially,
registrar.
You're opening a hole from the outside to the PBX. for
Yep.
registration.
Yep.
Yeah.
But it's based upon what parameter? How does it know? Can I mix open NAP and ACL based NAP on the same SBC?
Yes.
So I can have some NAPs that'll pass through and others that won't?
Yeah, exactly. So when we receive a SIP registration request, it needs to be targeted toward the IP that we have configured or the ACL, right? And or the domain.
But there's no way to have registration local on the SBC?
No, no.
For the NAP?
No, there's no registrar integrated.
Vous avez dit que du coup, là, vous filtrez surtout par la source list. C'est ça. Mais qu'est-ce que vous préconisez sur les clients nomades qui font du home office, etc.
Du quoi? Home office?
Pas d'idée fixe.
Pas d'IP fixe.
Pas d'IP fixe. Oui, c'est ça.
Qui travaillent à la maison, tu vois, il y a...
Yeah, that's the thing with the open NAP, right? We don't check the source IP.
Yes.
Right? It needs to be destined to a specific IP, but the source IP we don't check. So that works for remote workers. Right? Or you can say,
Hold on.
wait a second. You can choose from which you can choose groups of IPs. Now you can choose groups of IPs from which you receive from, right? Yeah, no, you can choose.
Subnet or something.
Yeah. You can choose a subnet. You don't have to be fully open all the time, right?
So that the IP on the SBC would be 192.168.1.0/6
Yeah. So this.
or something.
Yeah. So this is what I didn't do correct. Maybe here is you can have an ACL to block from other sources, right? Not exactly.
Okay.
But the destination has to be us. It has to be us, right?
Yeah, there's the other thing with geo IP that you can filter requests from
Okay.
countries. So
Right. That would be the kind of thing useful. Yeah, you would say only from Montreal or something like that.
Well, when you receive the registration, okay, and then you pass it on
Yeah.
to the
Yep.
device, you're passing it on with the FQDN that it tried to register with,
Yes.
right? Okay, all right. Same thing for any invite that comes in. You're always going to send it with the,
No, the other calls we will convert as it needs to be. So if we receive, if we have our techobridges.com domain and we receive a call at techobridges.com, but we need to send to something else, then it's going to be,
What I'm saying, let's say I have a phone out in the cloud.
Okay, yep.
Okay, and it's registered,
Yep.
let's say like XYZ Connexio. When it sends a call from the device, it's
Right.
going to send the invite, okay, with the Connexio cloud, and it's basically got to go there, because my switch will not accept it anywhere else.
anything else than the domain. Yeah, okay, so yeah.
It's got to be the fully.
So if it's registered, it's going to be like that, yes.
Okay.
Okay.
And even if it's not registered?
If it's not registered, no, I think we'll convert it, right?
So là, tu peux pas envoyer.
Unless, oh, wait a second, yes. Go ahead, Nicole.
Register is not, the code will be rejected.
Yeah, but no, but if we receive a call with a SIP domain, we can forward the SIP domain.
Yeah, well, we can route by the SIP domain, right? So that
Route by the SIP domain, but also forward it.
yeah. So
Yeah,
that
okay, sorry.
So that when it comes from this PBX, you want the code sent to this particular PBX.
Yes.
You want the code to send to another PBX or register, right? So it can be a router based on the incoming domain.
Yeah, and there's a specific parameter in the route to say forward SIP domain, right? And then you can set this to true, and it's going to forward the incoming SIP domain.
So as far as the registration, to go back to that though, essentially what you're saying is that the SBC acts as a traffic cop, kind of like a bottleneck for the registrations. And then it's just passing it through as a whole, straight up to whatever it is registered to.
Yeah.
Okay, and then once that registration is initiated, say for instance the phone is outside the network and has to make a phone call. That invite's going to go through the SBC to the PBX. The PBX then initiates the RTP.
Yeah, exactly. Yeah. Yeah.
But if it's a remote user on a PBX, what is the advantage of sending it through the SBC at that point?
Not on a PBX, it's like also like an IP phone. Right?
Well, if I have an IP phone on my desk at home,
Right.
but my PBX is based out of Montreal, my IP phone registers with the PBX.
That's right.
What is the advantage of sending it through the SBC?
Well, once you're registered, then you are protected, right? Then nothing else will go
Because
through.
it's a register-based phone, it doesn't matter, right?
It doesn't matter.
Well, so I'm still trying to understand why I would send it through the SBC in the first place. Why wouldn't I just allow the phone to register with the PBX directly?
Okay, if
That
you
means your PBX has to have a public IP.
exactly, and then all the other calls need to go through the public IP and
Okay, so in
So-
that scenario, the SBC is local to the PBX. No.
well, yeah, ideally it's the PBX is local on one side,
Okay.
and then you register with the public one,
Right.
and once you're registered, then everything is okay, right? The only part which could be tricky here is the part where if you get attacked on registration,
Right.
that's the part.
Yeah, no, okay.
So we have some protection, but maybe we don't cover everything there.
Good thought, for sure.
Once you register through the SBC to the PBX, then everything else passes through this path. Okay.
Does that count for the sessions as well with the registrations, or if I have, say I set up two SBCs, one to handle the registrations, one to handle my call path basically. If the call is initiated by a phone that's registered through the first SBC, that's just handling the registrations, well, if that passes does that count for the sessions on the license, or just
Well-
do as much as I want there, and then all the media is going this way?
Only the registration there's a specific license for that. It's 350,000, so that's pretty much unlimited. All right, so you can have many users registered to the system, but only the ones that have a real call will count as sessions. All right, so if you're registered but you don't make a call, it's not a session. Okay.
So there's a separate license for that kind of thing?
Yes, separate license.
Extension to extension calling is considered part of your sessions.
Yeah. Well. Okay.
I want to make a little supplemental.
Of course.
For James, the question about why they still put the SBC in front of the PBX, right? One of the reasons is to hide the PBX in the private network. The other one is that still the SBC can like block some of the registered message if they send a lot. Also the interval, like some phones, they keep sending this every second, then SBC receive it, but SBC does not forward it to the PBX. So SBC this is configurable, you can forward it every minute, but even though we receive it every second, so this is also another line of protection.
Yeah, that's in my next presentation.
No, that's good. That's great.
No, it's fine. It's fine.
Great idea.
But it will not block the registration. So if you have someone out there
Yeah,
that's
you
always
have-
trying to register, slamming.
Yeah, you do
Yeah,
have the
slamming
filter,
it.
I mean, you know a IP that this IP have, but it's true, but it's not automatic.
No, not
You
automatic.
discover
It's
it.
manual.
Yeah, there's manual to add
That's-
the
that's-
filter.
That's part of the problem, because all these hackers out there,
Yeah.
they're going off.
Find new ways of.
They're running bots.
They're going all over the place.
Yeah.
They're not, it's not hitting
The
the
VPN
VPN.
hack, yeah.
Yeah, for sure, there's some improvement.
Yep.
Look at those.
Exactly. Okay, so I've shown this before, but I just want to show you the configuration. This is also in the network access point configuration. So you can say, let's say maximum 200 incoming calls, maximum simultaneous incoming call 200. So when you reach 201, it's going to be refused. I'm not sure which error code, but it's going to be refused with a specific error code. And then, for example, maximum outgoing calls per second. So we will make calls out, but after 25 calls per second. So there's of course, a window of checking how many calls we send. So it could be not exactly 25, but around 25. And we will stop, not allow sending on this
What's
network.
that maximum incoming calls per second based on the whole machine?
Per NAP.
Based on a
This is
specific-
this NAP, this particular network, configured. Yeah.
But it's not, I mean, if I'm getting slammed, I can say, hey, this guy here, block it.
Yeah. So there's an automatic block which is configurable in the SBC,
Right,
but this one is an additional.
okay.
And the part you configure in the SBC, it's done very low level. It's going to be blocked right away if we see too many. Wait, we start receiving calls here. Here it's really in the system. So it went through the TB router in our system, and then we calculate. Oh, it's we received maybe 100 calls per second. Stop. Right. So we can block any more attempts.
How does it respond to the NAP? So if it blocks a call, does it send a?
Yeah, sends an error, but I'm not sure which one.
Okay.
Maybe 503 or something like that. Yeah.
Well, why would I want to block the maximum incoming calls coming in from one of my apps or one of my providers?
Yeah.
What's the reason behind that? Why would I want to block that?
All kinds of reasons.
Customer naps.
Oh, customer naps, okay.
Now, what about?
Customer naps.
Is it using the invites on the, looking at the SIP invites to do that, or is it looking at a different piece of it to calculate that?
These are invites, yeah, invites.
What is a burst?
So it's pretty media then.
Burst is a bit more, right? So let's say the mean is 25, but you could accept to go to maybe 40 sometimes for a short period of time. I'm not sure. Probably if we hover on this, it's going to tell you a bit more information. I don't remember what's the window we check, but it means that when you reach 26, it's going to accept it. If you put a call burst higher than this. Right?
Does it show in the log anywhere?
Yeah, sure.
So if I take CDR, can I, because we use bursting,
Okay.
so, and our carrier uses bursting, so.
Oh, do you see in the CDR if there was bursting? I don't know.
Nicole knows.
And what's the timing? What's the timing there, or how does it calculate the burst rate? What's the timing?
Yeah, that's what I'm not sure. That's what I'm not sure what's the burst rate. But there's certainly another window, maybe not 1 second, or it could be 1 second, that you can go more than 25. But after that, it has to be back to 25, or it has to be, maybe it's a full calculation. You can have 15, 40, and 25, right? If you understand what I mean. The mean should be more like 25, not just 25 over 1 second. I know, for example, you guys, it's 25, it has to be 25 per second maximum, right? You can't ever go over that, right? But that's on the outgoing network. So,
If you put 0 on incoming outgoing and you put a total call of 200, it's going to be mixed?
yeah, mixed. Here, it's going to be mixed. So if you put 0, 0, 200, then you could have 100 incoming, 100 outgoing. So that makes 200. Yeah.
Any combination.
Yeah.
Is there a report to see how many, what was the maximum simultaneous call for this NAP or?
Okay, so we used to have a module that was called statistics. It was not really well done, so we decided to remove that and go solely with SNMP. So it becomes then your responsibility to get those data every second, 5 seconds, 10 seconds, and capture how many calls you got in that period of time. So.
What kind of hit does the system take when you query this? Has it affected that much or not?
No.
Is it a different process?
Different process.
To do that?
Other cores, if you have enough cores. All right, if you're running on one CPU or two, maybe 2 CPUs, it's yeah, it has a little effect. But if you have enough cores for all your applications, then,
So you have another service there that's
Yep.
handling the SNMP query?
yes. So the impact is minimum. Of course, if you try to do it every millisecond, then that could be problematic.
Once a month.
Local network address translation. So what we do is that when you configure your NAP and you say you will be using, when you configure your NAP and you say you will be using a NAT, then you can say, well, in the messages we'll send a public IP. So you can configure what is the public IP you want to put in the SIP messages or the RTP messages, and they could be different. Maybe they're going to through 2 different firewalls. Okay? So you can do this. I thought there was another mode, but I didn't put it here. Another mode for public IP. Then you have the remote NAT for SIP. Okay, so there's 2 modes here. Either we validate the contact IP that we receive, or we use the IP port of the last SIP packet. So what we do is we open up the system and we wait until we receive something, and then we verify what we receive, and then we can accept calls coming from a system behind a NAT. Okay, so either we check the contact IP or we check the source, well, the socket IP of the message. Okay.
Lots of your customers use the SBC behind the firewall.
Yeah.
So this might solve some of the problems with the IPs you block requests. You have another, you block all the requests from certain IP range from the file.
No, but this we said we can enable, we can block IPs in the SBC, right? So you can choose the IPs you can receive from. Right? You don't have to be fully open. So you don't need a firewall to do that specific function, but maybe other functions. Yeah. But mostly the firewall used in this mode is really when there's only one public IP. Right? There's just one. You have one. So you cannot put it on the SBC because you want to receive all other type of traffic. So mostly used for smaller installations, let's say. Like the universal CPE devices we have tested. These are devices to be put at customer sites, and you have a network interface, and then you have a firewall, and then you have the SBC, right? Because it's all coming in through the same IP.
Now, the remote NAT, how does that help with customers who are like at a home, have like a little Linksys router
Yeah,
with
yeah.
SIP inspection enabled? Or SIP LAJ?
Nothing.
Ah, well, this I don't know.
I'm asking the question.
You're right, though, yeah, but it's not,
Unless you haven't changed the port registration form. I mean,
There's
Does it normalize it, or is it still a headache?
you have more experts than me on this here.
some are good, some are terrible. Some are like absolutely ridiculous.
yeah, the little link system.
We
somewhere.
run
Yeah,
into
Nothing you can do.
Zyso, and the worst part about that is especially like if the customers have their, get the modem from the carriers. Okay, carrier pushes an update, so
Yeah.
even though they went in and disabled SIP ALG,
That's
they re-enable it. You know, you gotta fight with them, and, believe me, I lived on my nightmares with that, so I tell my customers, no, just get the modem from them. You know, don't get the filter router, or whatever the case is.
Yeah, we do the same thing, but we'll ship them a little $50 router, just.
Yeah.
This will fix it.
Little microchip or something.
Yeah, that's exactly what we do. That's exactly what we do.
And then for RTP, it's similar, except we also check the port, all right? Because when we open our interface, we're just waiting for receiving data, RTP data, and then we verify what's the IP port, and we use that to send back.
So is this required when you're doing registrations, or when you're registering for phones that are out on the web?
Registration, I think we need to do it. Nicole maybe confirm with me. SIP registration, do we need to use the SIP netting? The remote SIP netting, this one? Sometimes we have to do it, right? But maybe not all the times. Not always, eh?
It really depends the
Yeah.
network setup.
Yeah. So I think the answer is maybe.
Or if there's, yeah, you can pay a capture to check if it's needed.
Would it hurt to turn it on, and even if it's not required? Is it one of those things where it's
Is it?
better to play it safe and have it on, or not turn it on, or only turn it on, you know?
I think you can still turn it on, but
Well, actually for SIP, it's pretty rare that we have to use NAT.
okay. So SIP is rarer, right?
Rare, yeah.
Yeah.
For the RTP, yes, it's pretty often that the RTP behind that, but
Yeah.
the SIP, because I think there's the firewall IP and there's the private IP and there's the mapping, so most of the firewall is going to handle.
Yeah, exactly.
To forward
If
it to the private IP.
exactly. If the firewall is well configured, then it's gonna pass and it's gonna be okay because there's only one port to configure. Problem with RTP is every time it's a different port. So how can you know? So the way to know is this. So I agree with Nicole. So SIP, not so often we need to set it up unless it's not configured correctly at the remote end. But RTP, yeah, more often. Okay. So we saw the SIP and IP interfaces and the network access point. So then the network access point we'll use to route information between different networks. Okay.
Now that you know a nap is more than a brief sleep. Alright, well that was a bad joke. But anyway, let's keep going on to the next module by clicking on the box over here.